Hello everyone and welcome to project 2nd in our machine learning series. Today we are diving into crucial application of machine learning, detecting Parkinson's disease. This project falls under the healthcare domain where AI has immense potential to make a real difference in people's lives. Early diagnosis can lead to timely treatment, which is incredibly important. So what is Parkinson's disease? It is a progressive neurological disorder that primarily affects dopamine producing neurons in a specific area of the brain. Symptoms often include tremors, rigidity, slow movement, and balance issues. Our goal is to build a machine learning model that can predict whether a person has Parkinson's based on certain voice based biomedical measurements. In this video, we will cover up the entire process from understanding our dataset, preparing the data, training a support vector machine model, evaluating its performance, and finally building a simple predictive system. So let's get started. You can download the Parkinson's CSV from this link. I will give this link in bio also, and you can drag and drop this in your Google Colab file. First things first, let's look at our data. We will be using a dataset containing various biomedical voice measurements from individuals with and without Parkinson's disease. We will start by importing our essential libraries. So we will import NumPy, we will import pandas from sklearn, model selection, we will import train test split, then from sklearn we will import standard scaler because we also need to scale our data. Then SVM, and finally we need to import the accuracy score dot matrix. Now let's load our dataset, which is a CSV file. Make sure the parkinsons.csv file is in the same directory as your notebook, or you can also provide the full link of copy of path of this file. We will give it name as Parkinson's data. Once loaded, we can get a quick glance at first few rows using the head function. It will give us the top 5 rows. Sorry, I forgot to put an N here. As you can see, we have many features. These are all different voice characteristics. The status column, as you can see here, the status column is our target variable. 1 indicates a person has Parkinson's and 0 indicates they don't. Let's check the shape of our dataset to see how many rows and columns we have. And a quick info tells us about data types also. This tells about the data types and non-null values. It's good to see no missing values here. We can also use the describe function. We can use the describe function to get statistical measures like mean, standard deviation, and quartiles for all our features. This gives us a good sense of data's distribution. Finally, let's look at the distribution of our target variable, status. This helps us understand if our dataset is balanced or imbalanced between the two classes. We want to ensure we have enough examples of both Parkinson's positive and negative cases for our model to learn efficiently. Now we will do data pre-processing. Now that we have understood our data, it's time for pre-processing. This is a crucial step in preparing our data for the machine learning model. First, we need to separate our features, the input data, to X, and our target variable, the output, as Y. The name column is just an identifier, so we will drop that as it is not relevant for our prediction. So I will give X as we will select everything except the name and status column. We need to give the axis as 1 because we are only removing these two columns. And Y as and we will select our status, the output variable. Now we split our data into training and testing sets. We will use 80% of our data for training the model and 20% for testing its performance on unseen data. So our functions will be xtrain, the next test, ytrain and ytest. From train test split, x, y, test, size into 0.2. 0.2 is nothing, it's just the test size is 20% of the total data. Random state I will give 2. You can give whatever you like, whatever you want. Now the most important pre-processing step for this dataset is standardization. So we will import scalar as standard scalar. Many machine learning algorithms, especially sport vector machines, perform much better when the input features are on a similar scale. Our current features have a wide range of values. Standardization scales the data so that it has mean of 0 and a standard deviation of 1. So we will now fit our extrain data. Now I will extend scaled, which will be equal to scalar transform of extrain. It is nothing, just the scaled version of extrain. Now we will scale the test data also. We fit the scalar only on the training data and then transform both training and testing data. This prevents data leakage from the test set into the training process, ensuring our evaluation is fair and realistic. With our data pre-processed, we are ready to train our machine learning model. For this problem, we will be using a support vector machine or SVM. As we have already called the SVM over here, imported from sklearn, we just need to use it right here. SVMs are powerful supervised learning models used for classification and regression tasks. In classification, SVM finds the optimal hyperplane that best separates the data points into different classes. Think of it like drawing a line that best divides your data points. The SVM aims to maximize the margin, which is the distance between the hyperplane and the nearest data points from each class. The nearest points are called support vectors. Let's initialize our SVM classifier. We will use the SVC class from sklearn.svm. We are specifying a linear kernel here. So we will call as model is equal to svm.svc support vector classifier. Our kernel we are using is linear. Once initialized, we fit our model to the scaled training data. This fit step is where the model learns the patterns and relationships within the training data to make future predictions. It's learning how to differentiate between the voice characteristics of people with and without Parkinson's. So we will now fit our data. Model.fit extrain scale data. We will be using scale data and y non-scale data trained. After training our model, the next critical step is to evaluate its performance. How well did our model learn, and more importantly, how well does it generalizes to new unseen data? We will use the accuracy score as our metric. First, let's check the accuracy on our training data. We will create a new prediction. Model.predict, and it will be predicting the extrained scale data. And now training data accuracy will be accuracy score from sklearn, and we will give the y train and extrain prediction. Now we will print accuracy as training data accuracy. We can see our model has a training accuracy of 88%. Now we will calculate the accuracy on our test data. It is similar as this. Instead of train, we will use test, prediction, and X test skilled data. Here the X test, prediction, and also the Y test data. So the accuracy of our testing data is 87, which is good. We achieved a really good accuracy score around 87-88% on both our training and testing data. This indicates that our model has learned effectively and is generalizing well, which is fantastic for healthcare applications like this. A high accuracy in both sets means our model isn't overfitting. Now for the exciting part, building a predictive system. This is where we can take a new unseen data, feed it into our trained model and get a prediction. Imagine you have a new set of voice measurements. We need to format this data exactly how our model expects it. We will create an input data tuple, input data, and then tuples need to be converted into NumPy array for numerical operations. So we will convert our input data as NumPy array. Which we can do by typing np.asArray, and in function we will call the input data. Our model was trained on scale data and it expects input a specific shape. Since we making a prediction for single instance, we need to reshape our array to tell the model that we are predicting for one sample with 22 features. The -1 automatically calculates the number of columns. So we will reshape our data. Input data reshaped is input data as NumPy array dot reshape. And just like we scaled our training and testing data, we must scale our new input data using the same scaler that was fitted on the training data. This is also vital for the consistent and accurate predictions. So scaling the new data, standard data is scalar.transform input data reshaped. This will scale our data as well. This gave us error because we have not entered any input. So we will input some values here. So we will paste the value of our data, but we should remove the one from here because it is the status value, and as we know from the training data we have removed the in the training data status column was not available, so we removed that. Then now we will run the cells and it is okay. Finally, we can make our prediction. The model will output either 1 or 0. So we will create a new function named as prediction model, which is equal to model dot predict. It will work on the standard data. Print prediction. Now based on the prediction, we can also print a user-friendly message like if prediction is equal to 0, then print person does not have Parkinson's disease, else print that the person has Parkinson's disease. So our model predicted very good. This shows how you can deploy your trained model to make real-time predictions based on new data. Imagine this integrated into a large system for medical diagnosis support. So to summarize what we have covered in this project, we learned about Parkinson's disease and its relevance in healthcare. We explored a dataset of voice measurement, performed crucial data processing to check null, not null, and shape and other things. Then we performed crucial pre-processing steps like splitting the data, standardization, trained a powerful support vector machine model, evaluated its impressive accuracy. Most importantly, we built a practical predictive system that can take new input data and tell us whether a person is likely to have a Parkinson's or not. This project highlights the power of machine learning in solving real-world problems, especially in vital fields like healthcare. If you found this video helpful, please give it a thumbs up, subscribe for more machine learning projects, and let me know in the comments if you have any questions or ideas for future videos. Thank you so much for watching. I will see you in next video.